Hello students, it is A.K. Jha chemistry classes. Today I am going to teach you the colligative property of solution. Colligative property of solution. Write down the colligative property. Colligative property of solution. What is colligative property? Colligative property means the property of solution which depends upon the number of particles or ions present in the solution. No matter what is its physical property or chemical property, the property depends upon the number of particles of solute. For example, if you dissolve certain amount of common salt or sugar in water, its vapor pressure decreases because the solute particles occupy the upper surface of the liquid and it hinders the evaporation of the liquid because the solute molecules take the position of the space from where evaporation takes place, resulting in less vapor is produced, and so vapor pressure decreases. This is called lowering the vapor pressure. So, relative lowering of vapor pressure depends upon the number of solute particles present in the solution. Similarly, boiling point also depends upon the nature of number of solute particles, because boiling point is that point where the vapor pressure of a solution equals to the atmospheric pressure. As the vapor pressure decreases, as I have told you before, because vapor pressure depends upon the number of solute particles. As the solute particles increases in the solution, less vapor is produced, so vapor pressure decreases, and in order to equalize the vapor pressure to the atmospheric pressure, which it requires more and more heat is required to equalize the vapor pressure of to the atmospheric pressure. Naturally, the boiling point of a solution increases. Hence, elevation of boiling point depends upon the number of solute particles. So, the elevation of solute particles is elevation of boiling point is also a colligative property. So, first colligative property of solution is relative lowering of vapor pressure. Second is elevation of boiling point or boiling temperature. Third is depression of freezing point. Depression of freezing point, it means the freezing point of the solution lowers as the solute particles is increased in the solution. I will discuss it later on. And the fourth is osmotic pressure. Osmotic pressure means the pressure exerted by a solution, a solvent, while it goes from higher concentration to lower concentration through a semi-permeable membrane. Semi-permeable membrane, the solvent particles exert pressure while it goes from higher concentration to lower concentration. So that very pressure, osmotic pressure, also depends on the solute particles, number of solute particles. So finally, there are four colligative properties of solution. So detail is not required to write down. Only I am writing you there are four colligative properties of solution. It is AK high chemistry classes, and now you will start writing, and I am writing. There are four colligative properties of solution. First is relative lowering of vapor pressure. Second is elevation of boiling point temperature. Third is depression of freezing point temperature. And fourth is osmotic pressure. I will teach you these four properties one by one in four videos and with some numerical problems also. So let us start first. Relative lowering of vapor pressure. बताओ इसको, लिख लिए सवाल में? Okay. So first, relative lowering of vapor pressure. Let us consider a solvent A whose vapor pressure in pure state is P naught A, and its mole fraction is XA. A solute, a non-volatile solute B whose dissolved in A whose mole fraction is XB. Clear? Since the solute is non-volatile, so वेपर प्रेशर लगेगा। ये अगर ये बर्तन है, इसमें कोई सॉल्वेंट A है और ये सॉल्यूट B है, तो वेपर प्रेशर of the solution will be only due to A, not due to B. So the vapor pressure of the solution is only due to the solvent A, only due to the solvent A. Clear? Vapor pressure P solution is equal to P naught A. It is due to PA, vapor pressure of solute, which is equal to P naught A into XA. There was the Raoult's law. Raoult's law, according to Raoult's law, the vapor pressure of a volatile component is equal to the mole fraction of the solvent and the vapor pressure of pure solvent. इसको मल्टीप्लाई करोगे, ये हो जाएगा। क्लियर? नाउ since जैसे XA plus XB is equal to 1, so XA is equal to 1 minus XB. We can write P solution. We can write P solution total pressure of solution is equal to P naught A into 1 minus XB. We divide P solution ऊपर से इसको मिटावे, इसको ऊपर से मिटाना है। This P solution divided by PA, P naught A equal to 1 minus XB. Clear? और this XB is equal to 1 minus P solution by P naught A, और XB equal to, this is P naught A, this is P naught A minus P solution. Can we see that this is the vapor pressure of A in pure state and this P solution is lower, so मैंने कहा है कि the vapor pressure of solution is less than the vapor pressure in of pure solvent. So this is called relative lowering of vapor pressure. इसको मिटावे मिटावे तो जिसे और here P naught A minus P solution divided by P naught A is called relative lowering of vapor pressure. Since the value of relative lowering of vapor pressure depends upon the mole fraction of solute, it means number of solute particles in the solution, hence it is a colligative property. Clear? Now you can calculate the molecular mass of solute also by this equation. So write down calculation of molar mass of the solute. Here xb is equal to nb divided by nb plus na plus nb. मतलब number of moles of solute divided by total number of moles present in solution, number of moles of solute divided by number of moles of solvent and number of moles of solute. For a very dilute solution, dilute solution, बहुत dilute solution रहेगा तो this NB is negligible in comparison to Na, so XB is equal to NB by Na. Hence this is P naught A minus P solution by P naught A equal to NB by Na. This is equal to molecular mass given weight of B divided by molecular mass of B by Na given weight of A by molecular mass of A. This is WB into this is MA. WB into MA divided by MB into WA. By knowing all these things, you can calculate the molecular weight of solvent MB. Clear? This is why the WB into MA by MB into WA is a relative lowering of vapor pressure. Clear? यहाँ एक इम्पोर्टेंट बात यह है, ये की बात करें, अगर सॉल्यूट की बात करें तो molecular mass of solute always remains constant. This Wb can be increased or decreased because weight of solute may be high, may be low. So number of this colligative property depends upon the weight of the solute, not the weight. I mean to say that number of particles of the solute will determine the relative lowering of vapor pressure or colligative property. Very important thing here is that this, if you say lowering of vapor pressure, only lowering the vapor pressure is not a colligative property. But if I say relative lowering of vapor pressure, then it is a colligative property. Clear? Now I am giving you a numerical problem and you will have to solve it. बता दो इसको बता दें. Now you see a numerical problem and you must remember some points as I have told you before also. Urea, molecular weight of urea, molecular weight of sucrose, molecular weight of glucose, molecular weight of cane sugar, यही 4 से तुमको मुलाकात होगी किसी भी क्वेश्चंस में. तो मैं लिख देता हूं कि सुक्रोज C12 H22O11 मोलिकुलर वेट 342 ग्राम पर मोल. इसको केन शुगर भी कहते हैं, केन शुगर भी कहते हैं. C12 H22O11 342 मोलिकुलर वेट 342 ग्राम पर मोल. ग्लूकोज C6H12O6 180 ग्राम पर मोल. यूरिया CO का होल 2, यूरिया CONH2 का होल 2 60 ग्राम पर मोल. इसको याद कर लेना है बिकॉज तुम्हारे लेवल में हमेशा यही 4 आएगा न्यूमेरिकल प्रॉब्लम में. एंड कंपटीशन यू हैव टू नीड नॉट कैलकुलेट द molecular weight, so you kindly you must have get by heart the molecular weights. And now I am giving you some numerical questions. So the formula is relative lowering of vapor pressure P naught A minus P solution divided by P naught A is equal to WB into MA divided by MB into WA, where WB मतलब weight of solute by molecular weight of solute, this mass of solvent by molecular by weight of the solvent WA. And now you take some question. The question is the vapor pressure of pure benzene. The vapor question. The vapor pressure of pure बेंजीन क्या होगा? C6H6 72 plus 6 78. Pure benzene molecular weight 78. 78 gram per mole at a certain temperature at a certain temperature is 0.850 bar. Clear? A non-volatile and non-electrolyte solute, a non-volatile and a non-electrolyte solute weighing 0.5 gram, weighing 0.5 gram is dissolved in benzene. Clear? It lowers the vapor pressure. It lowers the vapor pressure of the solution to 0.845 bar. 0.845 bar. यहाँ पर लिखा है वेपर प्रेशर घट जाता है यहाँ तक. अगर मैं लिखता बाई तो उसमें घटा दिया जाता, लेकिन इनिशियल वो था एंड सॉल्यूशन टू 0.845 बार. क्लियर? कैलकुलेट द मोलर मास. Calculate the molar mass of the solute. इसे मान लेंगे सॉल्यूशन. लेट द मोलर मास of solute is equal to mb. प्योर स्टेट में दिस वाज द 0.850. पी सॉल्यूशन का ये है 0.845 by 0.850 is equal to WB. वेट ऑफ द सॉल्यूट है 5 ग्राम. 0.5 ग्राम into MA. मोलकुलर मास ऑफ सॉल्वेंट है जैसे 78 डिवाइडेड बाय MB. मोलकुलर मास ऑफ सॉल्यूट इनटू WA. WA 39 ग्राम बेंजीन. इसमें एक और जोड़ना होगा कि वेट ऑफ बेंजीन इक्वल टू 39 ग्राम. दिस इज WA, weight of solvent. So you can calculate this. This is 39 gram. This is 170 कैलकुलेट करेंगे तो एमबी होगा 170 ग्राम पर मोल अप्रोक्सीमेट इसको निकालना होगा। इसको सब्ट्रैक्ट करके डिवाइड करना होगा, इसको निकालेगा, इसको निकल जाएगा। इस तरह ये बनेगा। जैसे 0.100 170 ग्राम पर मोल होगा। तो घटाओगे इसको, ये तो ऐसे रह जाएगा, ये हो जाएगा 39 हो जाएगा, बेटा ये कैंसिल हो जाएगा। जैसे 39 बाई एमबी 39 ये कैंसिल हो जाएगा, 1 बाई एमबी हो जाएगा। इसको सब्ट्रैक्ट करोगे, इसको 0.850 0.845500 इसलिए यहाँ लिखेंगे इसको, और जैसे 0.005 बाई 0.850 इक्वल टू 1 बाई MB। सो MB इक्वल टू हो जाएगा, MB इक्वल टू 0.850 बाई 0.005, इसे 170 ग्राम पर मोल। आंसर क्लियर? इसको सॉल्व करना है इसी तरह से। नाउ नेक्स्ट वीडियो में करेंगे, पढ़ाऊंगा elevation of boiling point and also discuss how it is a colligative property. So God bless you, thanking you, and best of luck.